Anything now?
Not yet.
Yeah. That's it. Still nothing.
I can see it now.
Yeah, so which means it's sharing. Okay. So we're supposed to start with the ones which we're talking about, the oxidizing agents. We said organic molecules are fine. Is that what we are doing? Or you
Yeah,
need to browse, then we see if we are done with the organic, then we can clarify that no, we have refreshed the memory so that we know that this topic, if you are saying it's easy, which means it won't take us 2 or more sessions to just revise or to go through the session, the organic chemistry. So that whether you wanted to ask, you can still ask, then we clarify. You still remember, like last time we were talking of positional isomers, then structural isomers.
yes.
Wanted to us to clarify. So that's why I was asking, why don't we just browse through this one? Then we know organic now. We'll be just posing some questions. Any organic problem, we can just send it so that we know that we are done with the section. Then we can move to the app. I don't know how you see it.
Okay. Yeah, that's fine.
So let's just browse the organic. So last time when we discussed this, we ended where we were talking of positional isomers and also functional isomer, where we indicated that these are isomers where the functional group of the molecule has changed. In other words, the compounds still have the same molecular formula but belong to a new homologous series. That is when we're talking of functional isomer, for example, we are having 2 carboxylic acid and esters. They still have the same molecular formula, but now they belong to a different homologous series. The other one is an ester, then the other one is a carboxylic acid. As you can see, the CH4H8O2, both are same molecular formula, but different homologous series. Okay. The other one is a carboxylic acid, then the other one is an ester. So we'll be doing questions relating to this. So for example, you can have an aldehyde and a ketone, which means these two, they are having the same molecular formulas.
Formula.
Yes, but they are belonging to different homologous series.
Functional.
Yes, they differ. The homologous series is what is different. So here where it's written 5, it's supposed to be a 6. Are you seeing that there are 6 hydrogens here? 1, 2, 3, 4, 5, 6. Can you see that there are 6 hydrogens? Are you seeing 6 hydrogens? 1.
No.
This is 1, 2,
Yes.
4, 5, 6. So we are saying there are 6 hydrogens. So where we need to correct, where there's a mistake, we said the same molecular formula. So which means this number here, it's not supposed to be a 5, but a what? 6.
C3H6.
Yeah, so this is supposed to be a 6, not a 5. So there was a mistake there. Supposed to be a 6. That's supposed to be a 6. So that it can match. So we are saying same molecular formula, which means the molecular formula, but different homologous series.
molecules.
Right. So here they're just saying write the general formula for the alkanes, alkenes, and alkynes. We are just refreshing our memory. We are not saying that you don't know it, you already know, but we are refreshing the memory so that when you are doing questions, your memory will be refreshed. So for alkanes, just the general formula CN H2N plus 2, and alkenes is CN2N. Then
NH2,
yes, alkynes, butane, propyne,
CnH2n.
minus, yes. So you should be familiar with the formulas. So the homologous series to which the following functional groups belong and provide the name associated with the functional group. So 2.1,
2.1 alkanes, 2.2 is alcohols, and 2,
or 2,
2.3 is carboxylic acids.
2.3 is carboxylic acid, and then 2.1 you said what?
There's alkanes,
Alloalkanes, and then 2.2
alcohol,
alcohols. So here you are saying these are yellow alkanes. Then the other ones you said these are alcohols. And then the last one you said it's what? COA.
carboxylic acid.
Yes, carboxylic acid. So you are correct. So they can call them haloalkanes or alkyl halides functional group, which means you are putting group 7 elements. So halide group, which is also correct. So it's another way of writing it. Or the other one is the hydroxyl functional group, the carboxyl functional group, which is a carboxylic acid, which is correct. So name 3 types of structural isomers and explain the difference in each. So with the structural isomers, so we said for structural isomers, what do they have? What do you look at for structural isomers?
We have functional isomers. Functional isomers are molecules, organic molecules with the same molecular formula at different functional groups. We have chain isomers. Isomers are molecules with the same molecular formula but different side of the chain. And we have positional isomers. Positional isomers are molecules with the same molecular formula but different positions of the functional group.
Of the functional group, yes, is correct. So the chain isomer, like what you said, same molecular formula, but different types of chains. So the formula is the same, but different types of chains, which we are having. And then we are having the positional isomers, like what you just mentioned, which is the same formula, but different positions of the side chains, or it can be different positions of the substituents of the functional group on the parent chain. The functional group we mean the double bond, right? The functional group, which means the double bond, it can be the OH bond or the COOH bond. That is the functional group on the parent chain, which is the longest chain, and also the substituents, which mean those side chains. Whether are we having a CH3 where it's surrounding an atom, how many of these CH3s they will be surrounding that particular atom? The methyl, is it a methyl? Is it an ethyl, etc.? So for functional isomer, we are referring to the same molecular formula but different functional groups. So this one we have mastered it. So let's move on. the next one. All right. So here we are just saying explain the following terms. What is meant by a homologous series? A homologous series, what do we refer to a homologous?
Um,
And you can just give an example.
a
For example, what do you mean when you're talking of homologous series? Homologous series, what are we referring to?
homologous series,
Yes.
homologous series are compounds that can be determined by the same general formula. For example, the
That's what
general formula of King's.
that's what that's what it. All right, let's continue. Sorry, I was just having another call here. Let's continue to what we have been doing. You said homologous series.
Homologous series are organic compounds that can be described by their general formulas.
Okay. They have the same general formula. Is that so?
Yes,
Okay.
yes.
What about functional group?
A functional groups are a group of atoms that determine the physical or chemical properties of a compound.
Okay. What about hydrocarbon?
Hydrocarbons are organic compounds that contain of carbons and hydrogens.
So if I have CNH3, is it a hydrocarbon?
No, it's not.
So it must be hydrogen and carbon only.
Only.
Only. That's correct. So let's just give feedback. So we are saying a series of organic compounds that can be described by the same formula, which means we are referring to a homologous series. A series of organic compounds that can be described by the same general formula or in which members differs from the next with a CH2 group, which means the formula is just changing with CH2, then you know it's a homologous series. And then also for functional group, we are talking about a bond or an atom or a group of atoms that determines the physical and chemical properties of a group of organic compound, just like what you mentioned, which is correct. Then a hydrocarbon is an organic compound that contains only. So the keyword that you did not mention there was only. You should include it to say carbon and hydrogen only. Carbon and hydrogen only in a hydrocarbon. So hydrocarbon, it must have carbon and hydrogen only. Atoms in its structural formula. That is the key word. Then here we are referring to explain the difference between a straight alkane and a branched alkane. So a branched alkane and a straight alkane. How does it go? It's a branched one. The difference with a straight alkane. How is it differs? You just want to hear your explanation. I know you know this. The straight chain alkane and the branched alkane. Explain the difference.
Um, I
How do
could
they?
say
Yes.
they
Now,
differ.
How do they differ?
We say we have the same molecular size, but the difference is that the intermolecular forces on the straight chain are harder to break than the ones on a branched chain.
Yes, that's correct. So the straight alkanes are hydrocarbons where all the carbon atoms in the structure are in continuous chain with single bonds between the carbon atoms. So we are talking of single bonds between the carbon atoms. Okay. Then the branched alkanes are hydrocarbons where the side chains are attached to the parent chain, and you can also add to the intermolecular forces as well. That the longest chain is hard to break, but the smaller one, it's easy. And also the melting point and the boiling points of those compounds, they also differ. What name is given to the branch that comes off the carbon chain in branched alkanes? So when you are talking of those branches, for example, we are having carbon, 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 and then it's branched. Then we have another branch which is somewhere there. What do you call this branch? What do you call that branch? This branch, what do you refer to? So name, what name is given to the branch that comes off the carbon chain? Yes. What do you call that one? What do you refer
It's
to that? But you don't know whether it's an ethyl group or you don't know whether it is a methyl group. You don't know whether it's an ethyl. So will you give which general name do you give that branch? What branch? You call it a what? That branch.
side
It remains
chain.
the side chain. Okay.
Yeah, I
Side
think
can also be acceptable, but we call it an alkyl substituent. So these ones are alkyl substituents, which meaning it can be any substituents that is coming, it comes off a carbon chain in branched alkanes. So those side chains which you are referring to, we are calling them substituents. And what type of substituents? Which means alkyl substituent, which means you can call it an ethyl, which means if there are two carbons, a methyl, which means it is a butyl substituent, depending with how many carbons there are there, isn't it? Is it clear that one?
yes.
Okay, so let's move on. Let's move on. There, just asking what is the difference between a saturated and unsaturated hydrocarbon? So this one, they come to multiple choice. What is the difference between saturated and unsaturated hydrocarbon?
In saturated hydrocarbons, there are like no multiple bonds between the carbon atoms, and in unsaturated hydrocarbons, there are one or more multiple bonds between the carbon atoms.
So which means separated in saturated hydrocarbons, we are talking of single bonds, isn't it?
Yes.
Only. And then where it's unsaturated, we are talking of double bonds or more, again,
Multiple
double,
bonds.
triple, etc., isn't it? That is the
Yes.
difference. Okay. So saturated hydrocarbon is only single bonds between all its atoms, and unsaturated hydrocarbon is hydrocarbon which has double or a triple bond between one or more of its carbon atom. So by that, what do we mean? For all, if it's saturated, which means all the bonds which we are having, they are single. But these ones, they can be double bonds between, or we can have triple bonds in between, etc., isn't it? Then that molecule or that hydrocarbon becomes unsaturated. Any question there? Any question there
No,
regarding
no.
saturated and unsaturated? Any question? No question.
None.
Right. Then we go to the IUPAC naming about the structural formula. Then we have the condensed structural formula. Then you have the molecular formula. So that's what we'll be doing. The structural formula, condensed structural formula, then the molecular formula, etc. So we'll be working on this one. So structural formula, and what is the name of this compound? Organic compound. What is the name of this one?
Butene.
Butene. Butene or butane?
Butane.
Butane. Because of 4 carbon. So its condensed structural formula, this is a representation in a less complex way. Instead of drawing, now we are representing what we are seeing there directly. So we are representing it in a less complex way of representing the organic compound, where the bonds to each of the atoms are not shown. So please note that all the bonds between the carbon and the hydrogens in the molecule are still present. Looking at the full structural formula, yeah, looking at the full structural formula, the molecule represented above show the learners the condensed structural formula of this. So which means we are taking as it is. What we are seeing there, when it's condensed, you are reading this as CH3. So you come to CH3. What do I write next?
CH2.
So CH2. And what should I write next?
CH2.
CH2. And then lastly,
CH3.
CH3. You indicate CH3. Like that. So that is the condensed structural formula which you are referring to. Okay. So the one that is left now, you have the structural formula, which is the structure, which means you have to draw the structure. So when the question comes, if they say draw this, write down the structural formula, which means you have to draw. And they say give us the condensed structural formula, which means after you've drawn, how does it? We don't want to see the bonds. We don't want to see the bonds. Then the molecular formula, now you sum up how many carbons in total and how many hydrogens in what in total. That is the molecular formula. Any question there in terms of
No.
question? All right. So just in general, if there is 1 carbon, we call it a what? A methane.
No.
Yes. If they have 2, we use it depending on the number of carbon atoms. So for 3, it's prop. 4, it's bute. Then 5, pent.
And
And then 6, it's hex. 7, it's hept. 8, it's oct. What about 9?
non.
None. What about 10?
Deck.
Deck, yes, which is correct. Deck. But normally, we don't reach much there. Normally, the side chains up to 8 for the level of metric, it's fine. Okay. So which means if it's an alkane, it's an alkene, if it's an alkyne, if it's an alcohol, which means it ends with an propanol, pentanol, butanol,
Only.
carboxylic acid, which means butanoic acid, methanoic acid, pentanoic acid, etc. If it's an ester, which means it's a methyl pentanoate, isn't it?
Yes.
Butyl ethanoate, etc. Propanyl, butanol, if it's an aldehyde. And if it's a ketone, which means propanol, butanol, pentanol, etc. Okay. So these are the examples where we are putting the labeling and the naming. Carbon, which means 4 carbons, butane, 5 carbons, if it's an alkyne. So on alkyne, which means you represent it as the pentyne. Then Y, propanol, It's an alcohol. Carboxylic acid has hexanoic acid. Okay. Then for haloalkanes, which means it's bromobutane, if it's having a side chain, bromobutane, which means bromine is the substituent, which is a halide chain. So these are just, we are refreshing your memory. We have not started with the big deal here. So these are the side branches which we are talking about. We call them the alkyl substituents or the alkyl group. Which one is the alkyl group here? It's this one. This is the alkyl group. And this is our longest chain, which we are referring to as the parent chain. Is that clear?
Chain.
Yes, the parent chain, the parent group, the longest group. So that one is the alkyl substituent. So this one, referring to that. So here, if you check, if it's one carbon, which means it's a methyl group. If there are two side branch, two carbons, which means it's an ethyl group. Okay, like what we mentioned earlier. So in this one here, the longest carbon, it has 4 carbons, etc., which is very easy to notice. Okay, and then they are asking what is the alkyl substituent, which was the methyl. So the alkyl substituent is this methyl, which I highlighted, since it's having one carbon, the methyl group. And then the next question is saying number the main chain so that the alkyl group is on the lowest numbered carbon. So which means the lowest numbered carbon, instead of naming from this side, where do you start to number your carbons? Do you start from the left or from the right? Do you start counting 1 here? From the left, isn't it?
Yes.
So which means this is number 2. Instead, I should not start from the right, because if I start at the right, which means 1, 2, so this will be at 3. So the rule there is saying when you are naming these ones, when you are naming you have to make sure that it's at the lowest. So they are saying number the main chain so that the alkyl group is on the lowest numbered carbons. This will be number 2 as will be the lowest number if numbered from the left to right. So if you number from left to right, number 2. So it will be 2. Where is the substituent located? So put the name together, which means the alkyl comes before the main chain, meaning before you name the butane, which means you put the alkyl first, the alkyl group, which is that side chain, methyl. Is there a problem there? It's just telling us that on carbon number 2, there is a methyl group, which we can see here on carbon number 2. Which one is carbon number 2? This is carbon number 2. There's a methyl group. That is the hint that we are given by that name. So we have talked about the molecular formula, condensed structural formula, and then the structural formula. So in this case here, before we go there, and then the hyphen, you can also note that the hyphen must separate the number and the name at all times. It is also important for learners to be able to write the condensed structural formula for the branch chain compounds. This example will be written as follows. For example, which means we have CH3, CH, CH3, CH2, CH3, exactly as what we are seeing there on the branch. So we are naming it exactly as what we are seeing here on the branch. So we have CH3, that is our CH3 that we are having. Then we have CH. So the CH is this branch, which is down here. The CH is this one. So you have indicated that CH with that branch. And then the other one, CH3 is for the methyl group. And then you continue your chain like that. Any question of the condensed structural formula? It's fine. Then the branched chain organic compounds, the double branch. So here it find out is double branch, which means we have two branches. This is the first branch that we are having. This is the second branch that we are having. It's two branches. So we now move on to examples where there are two branches on the main carbon chain. So naming is exactly the same, except now both alkyl groups must be on the lowest carbons on the main chain. The lowest position will be carbon number 2 and 3 if numbered from left to right. So you always choose the lowest. If you are number from right to left, which means I'm going to use 1, 2, 3, carbon number 3 and 4. But if I use from left, I use carbon number 2 and 3. So that's why I have to come to number from the left to right, which this one you already know. And then the name, because it's 2, 3, which means there is a side chain or a alkyl substituent at carbon number 2 and carbon number 3. So carbon number 2 and carbon number 3, it's a 2, which means 2 corresponds to dimethyl pentane. If there were 3, how do you replace the di? You replace di with what? If there were 3, tetra. With tetra, isn't it? Yes, with tetra, which is correct. Now, the position must be separated by a comma, which means those positions where there are this alkyl substituent to use a comma, not a hyphen, and the word di must be placed before the alkyl group and named to indicate the two alkyl groups in the compound, of which this we already know. There's nothing much new there, just refreshing our memory. This is the condensed structural formula. Okay. Naming of alkenes, alcohols, and ketones. So we say position of the double bond. Can you try number 1? Just to refresh memory. It's an alkene already, but what is the name?
Pent 1 in.
And because of 5 carbons, which is correct. Pent 1 in. And then that one, it will be pent 2 in. Or if you want, you can write 2 pentene, isn't it?
Yes.
You can write 1 pentene, but 1, sometimes they just write pentene without the 1, which is correct. Then the condensed structural formula, that's the condensed is what it looks there. So you have CH2, and then you have a CH, then you have another. So you'll be moving according to the bonds, how the bonds are attached. So you start with the CH2, then CH, then you move to the CH2, 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 then you have CH3. So how many CH2s? We are having 2 and then CH3. That is the condensed structure. Then we have the halide, alkyl halides, where we are adding group 7 elements. So you have to tell us where is the position of that alkyl. For number 2, the position is at carbon number 1. Then for the second one, which is on the right, this one, it's at carbon number 2. So the name will change, yes. So first you start with the position of the group 7 element, which is the halide group. Condensed structural formula, which is CH2, which means it's at carbon number 1. then Cl, then you continue with everything. The first one is CH3, then CH, Cl, then you continue with the other side chains on the condensed structural formula. Note there are no brackets around the Cl atoms as there are not branches. So don't put brackets. They are not branches. Only if there are branches, that's when you put brackets. Are you seeing the branch that we are having there at CH3? CH3. Are you seeing the branch?
Yes.
So where there are branches,
Yes.
that's where you put what? That's where you put the what?
Brackets.
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 Yes, that is CH3. If you don't put brackets, it will seem as if it's a long chain. But brackets are indicating to you that that is a side chain. That's a side chain. So that is the difference. With brackets, I know that there is a side chain. But if there are no brackets, which means it's a continuous long chain. That is the only difference. Okay. So we are still refreshing our memory, so which means there are no brackets. Don't have to put the brackets on the condensed structural formula. No brackets. There are no brackets. All right. Alcohols, you know an alcohol because of the position of the OH group. Check how many carbons in the longest chain, which means we're having 5 carbons, which means it's spent 1 or carbon number 1. So that one's carbon number 2, which means it's spent 2,
All.
no, spent 10,
Mm.
2 all. Yes, like that. Or you can write it as 2 pentanol, etc. It depends on how you want to write. Both ways are acceptable. Either you can write like this, or you can write as 2 pentanol. It's also acceptable. Then we know the position of the OH group is at carbon number 2. Then the number, the main chain, so that the OH functional group is on the lowest carbon. So you always just the same method, the number. So the number, this one, is indicated between the suffix and the prefix of the name. So now introduce the learners to the concept of primary and tertiary alcohols, so which means now we want to know, is it a first degree, second degree, etc. So primary alcohols, these are alcohols where the OH group is placed at the end of the longest chain, which means you are in the OH group at the end. This OH group is at the end. So it becomes a primary what? Alcohol, which means the group is at the terminal. It's not surrounded by any, that carbon, which is having the OH group, it's at the terminal, which means these alcohols, the OH group is placed at the end of the longest chain in the, i.e. carbon number 1. So the OH group is attached to 1 carbon atom. That's where it's attached. So butanol, which means butane 1 all, it's a primary alcohol. So the next second example of a secondary alcohol, now we are checking, these are alcohols where the OH group is bonded to a carbon atom, which is bonded to atom. So which means the carbon, we are simply checking the carbon atoms, which is attached to the OH, this carbon atom which is attached. How many other carbons is it attached to? Is it to 1? It's to 2. If it's to 2, which means it's a what? The secondary.
Secondary alcohol.
And then the first one, the carbon which was attached to the OH, it was attached to only one carbon. That's why it's a primary alcohol. So the carbon that OH group, it was attached to only one carbon, which is this one. Then on the secondary alcohol, the carbon which you are referring to is attached to this carbon, which is 1, and it's attached to this carbon, which is 2. So it becomes a secondary alcohol. Then tertiary, which means you expect how many? 3, isn't it?
Other
So,
from
yes. So these are alcohols where the OH group is bonded to a carbon atom, which is bonded to 3 carbon atoms. Then you know it's a tertiary one, alcohol.
alcohols.
Any questions? Or it's clear? You know, organic, we say
Yeah,
they are memory. They are
it's
just,
clear.
yes. So 2, you name the methyl. So which one starts first? The methyl, is it the substituent or is the position of the OH? What comes first?
The substituent.
The substituent, the alkyl substituent comes first. So first you mention the alkyl substituent, then you tell us that there is a methyl butane. So methyl butane 2-ol, meaning on OH is attached on carbon number 2. And that is what we are referring to as a tertiary alcohol. Or you can also use 3-methylohexane 3-ol, which means if the methyl group is at carbon number 3, and also the OH group is also at carbon number 3. So that's how it is. And we say side chains, you always what? Side chains, you always put them in brackets. Isn't it? Yes.
Yeah, oh yes, yes, yes. Yes.
Bracket on the condensed structure or what?
Formula.
On the structural formula. On the condensed structural formula, they should be in brackets. Okay. And then also the ketones. We are seeing for the ketones, the main chain must be numbered so that the CO, you must see the C carbon and oxygen double bond is on the lowest carbon. So this position is indicated between the prefix and the suffix on the name. For example, we are saying butanone. Butanone. And then we are having the other one on the right. You check the number of carbon, there are 5. So it's pentanone. So the key word, which the key functional is this functional group, the CO bond. It tells you that it's a what? It's a ketone. Propanone, butanone. And where is the position? Indicate the position. So it's just refreshing our memory that once we are done with organic, we can start throwing questions here and there. We practice until you write. Then carboxylic acid and aldehydes. So carboxylic acid, we said COOH, isn't it? This one. COOH. Is it clear?
Yes.
COOH. So there is a double bond, and also if added an OH, it becomes a carboxylic acid. So this one is the propanoic acid, which means 3 carbons. Butanoic acid, which is 4 carbons. So those ones are carboxylic acid. And then the aldehydes, the propanol, butanol, etc. So instead of COOH, now we just have COH. First, we started the ketone, CO. Then we go to the carboxylic acid, COOH. Then now We are here where we have removed that OH with just CO and then with an H. So this is the functional group where you know it's a propanol. CO and then H. Whenever you see CO and then H, you know you are dealing with a propanol, butanol. And then when you are dealing with COOH, COOH, then it's a carboxylic acid. Then you have CO, which is a ketone. So those are the tricks when you are solving some questions. Then we are having some esters. So on an ester, which means we are having two things that we must. So let's read just a few summary. It must be emphasized that esters are derived from alcohol. So we are having an alcohol and a carboxylic what? Acid. So the first part of the name is derived from an alcohol. So always when you say propyl, it's coming from propanol. That is, the first name is derived from an alcohol. The part of the O, which is indicated by the alkyl group, the second part of the name here is derived from the carboxylic acid. So in an alcohol and the carboxylic acid, we form those esters. So it's attached to the CO. So which means you call it the alkanoate. So the COO. So this is how you see that this is an ester. You are able to identify this on your structure. Once you identify this on your structure, then you know it's an ester. So we said the first group, it comes from the alcohol, propanol plus ethanoic acid, ethanol plus propanoic acid. So it's a carboxylic acid, you get ethyl propanoate, propyl ethanoate, etc. Any question there?
I have none.
And the way you are writing the condensed structural formula is the way you are seeing it. CH3, you are seeing CH3 there, and also you put your CH3. CH2, CH2. OOC, CH2, CH3. The same way you are seeing it there on the screen. That's how you also write the way you are seeing it on the structure. CH3, COO, CH2, CH2, CH3. Then you are done. It's very easy organic. You can totalize everything. If you understand, there's nothing difficult with organic chemistry. Then an example, we are talking of methanol plus ethanoic acid. So we said the name ethanol plus ethanoic acid, then it will be methyl ethanoate. Methyl ethanoate. All right. So draw the structural formula for the following organic compounds. So we are having these ones. You want to try them the last few minutes? Hello?
Yes.
You find them easy. You can sketch them. The only challenging one is number
I'm
1.3.
quickly doing.
Eh?
I'm quickly doing it.
Yes. Then you forward it on WhatsApp. The picture, you take a picture when you're done. Let's see how fast you can do these ones for the last 8 minutes which are left. Yes. That we just check. So draw the structure, the structural formula. So here we want the structural only, not the molecular, but the structural formula for the following compounds. When you're done, you just send a picture on WhatsApp, then I open it.
Can you please go down? Oh, I'm done.
Yeah, it's only ending here. Yeah, done. You
Yeah,
forward
I'm
me.
sending them.
Yeah, send. Let's see. Just see how good we are at these ones. Yeah, done. Let me know. Have you sent? Hello. So 3-methyl heptane. So which means we have a alkyl substituent. So the alkyl substituent is there. So which is correct. So this is our alkyl substituent. This one is correct. And the longest chain, it's how many carbons? The longest chain
6.
has to be methyl. The longest chain is how many carbons? 6 or 7?
6 carbon.
The
6.
heptane is what? The heptane is what?
It's 7. 7.
7, isn't it?
Yes.
So how come you put 6?
It's a mistake.
A mistake. So that's how marks they disappear in the exam. Ne?
Yes.
So it has to be, we're supposed to add another one, isn't it?
pH3.
Yes, we're supposed to add this one. So the 100% would have disappeared now because of C. We're aiming for total. Then for butanol, which means want to work on this one, which means the OH is on carbon number 2. OH is on carbon number 2, which is correct. So you use the lowest numbers. Then ethyl methanoate. So ethyl methanoate. So which means the ethyl, it comes from ethanol, and the methanoate, which is 1. So which means which is correct. So which means this is our functional group of the ester. Ethyl methanoate, which is correct. Is correct. Which is correct. So you must correct those ones only those ones that we have missed. Right. So we'll continue tomorrow from where we have left. So this is the structure. Said it must have 7. 1, 2, 3, 4, 5, 6, 7 carbons. It must be number 3. The one which you drew, 2 is correct. Then the last one, ethyl methanoate, which was correct. So we'll finalize tomorrow. Organic chemistry, we are trying to push it so that we just finish it. It's just few questions, then we can go to those problematic questions. So now we'll be going to reactions. This one reacts with this one, and then what do you produce, etc. Then we are done. So maybe roughly tomorrow or Thursday, then we'll be done. Then we can go to the questions that are giving you trouble. Okay.
Okay.
All right. So let's stop here for now. We are done. Let's stop here for now. Then we'll continue tomorrow.
Okay.
You said you're writing June.
Yes.
There's still time, which means you are going to totalize it. You totalize it, definitely. Okay, let's stop here for now. Tomorrow, same time, okay?
Okay.